From nuclear power plants that power millions of houses to atomic weapons that can destroy just as many buildings, all of it is powered by one not so little reaction called nuclear fission. Nuclear fission is an exothermic reaction that occurs when a large nucleus splits into two smaller particles. It was first articulated by two German scientists, Otto Hahn and Fritz Strassmann. The reaction is often triggered by neutrons hitting a heavy nucleus. When that happens, the nucleus splits into subatomic particles or even gamma rays. The release of a few neutrons and a massive amount of energy also results from the reaction. Fission occurs because the electrostatic repulsion created from the large number of positively charged protons in a heavy nucleus. The stability of having two smaller nuclei with less electrostatic repulsion is essentially what drives the reaction. The reaction almost always occurs with uranium, the heaviest known element belonging to the actinide family. Its most common naturally occurring isotope is uranium-238, although there is no way to make this natural uranium metal into a bomb or use it in a nuclear power plant. Its only isotope that can undergo nuclear fission is the unstable atom of uranium-235. Additionally, the reaction can also occur with plutonium-239. If the fission reaction isn't controlled, a chain reaction could occur. This is when the additional neutrons released from an initial nuclear fission reaction could cause other uranium atoms to split, which could then trigger the nuclear fission of more and more nearby atoms. In order for the reaction to work, scientists have to first enrich a sample of uranium for it to contain 2 to 3% more uranium-235, which would be sufficient for nuclear power plants. However, to make weapons, the sample needs to be at least 90% uranium-235. On the topic of weapons, powerful explosions can be created from nuclear fission under two conditions. First, the reaction should be controlled in such a way that there is a low number of neutrons lost to fission. Second, the speed with which the chain reaction in the bomb proceeds should be very fast. It's critical that most of the material successfully fissions before the bomb blows itself up. In studying nuclear chemistry, you may have heard Albert Einstein's famous equation pop up a few times, but what does it have to do with nuclear fission? In those reactions, if you calculate the masses of all the particles you start with and compare it to the masses of the particles after the reaction, you'll find that the numbers don't add up. That's because matter is lost and converted to energy, and this missing matter is called the mass defect. Einstein's mass-energy equivalence formula can be used to calculate that missing mass as well as the amount of energy produced by the reaction. E denotes the energy released, M is for the mass defect, while C stands for the speed of light.
This is one example of a fission reaction that may occur in nuclear weapons. It produces krypton-92, barium-141, 3 free neutrons, and a large amount of energy. This energy is mostly released as the kinetic energy of the escaping particles, which is transferred to the environment as heat. Sometimes, the energy is also released as electromagnetic radiation. If you're given 5 moles of uranium-235 in the same chemical equation, it would have to react with 5 neutrons, resulting into 5 moles of krypton-92, 5 of barium-141, and 15 free neutrons. If, for the same reaction, 36 free neutrons are produced, then there would have to be 12 moles of uranium-235 reacting with 12 neutrons that would also result in 12 moles of krypton-92 and barium-141 each. Continuing with the same reaction still, if there are 23 grams of uranium-235, then it would result in 9 grams of krypton-92 and 14 grams of barium-141. The following are 2 other examples of fission reactions occurring in nuclear explosives. The total energy released by the fission of 1 atom of uranium-235 is about 3.5 times 10 raised to negative 11 joules, and 1 mole of uranium-235, approximately 2.1 times 10 raised to 13 joules, is released.
While the application of nuclear fission has its fair share of supporters, there are also plenty of people against it, and understandably so. Nuclear energy in general has a considerably negative impact on the environment. One such example is how the wastes generated from the mining and enrichment of uranium causes fossil fuel emissions from nuclear power plants and may contaminate water sources with radioactive substances. Nuclear accidents, while a rare occurrence, have devastating effects on people's health. In the Chernobyl accident of 1986, 4 nuclear power stations were destroyed, causing multiple people to die or fall extremely ill from exposure to radiation. The primary concern, however, is that our knowledge on nuclear fission poses a national risk. Reactions of this kind can create weapons and bombs that could potentially wipe out the entire world if a nuclear war were to break out. It would kill millions, cause a crash in global temperatures, and render us unable to grow crops for a long period of time. The infamous bombs that were dropped in Hiroshima and Nagasaki in 1945 during the Second World War were made with nuclear fission of highly enriched uranium-235 and plutonium-239. Up till now, the residents are still fighting the adverse health effects brought on by the extreme radiation their people were exposed to. Though it's undeniable that nuclear fission can bring a great amount of damage to the world, it should also be acknowledged that they've helped quite a bit too. Nuclear power plants make use of the energy released in fission reactions to convert water into electricity that powers hundreds of cities. In 2009 alone, atomic energy accounted for 14% of the world's electrical production. Perhaps its greatest advantage is providing an energy source that doesn't release carbon dioxide or other forms of toxins into the atmosphere.
It is never our scientific knowledge or technological advancements that cause adverse effects to the environment or to people. It always depends on how we decide to use all of that knowledge. We have the choice to use it to either destroy our world and hurt other people, or to make the world a better, more comfortable place to live in.